For this question, we want to draw a picture and set up the proper integral to find the area. We're going to answer the question as well, which means we're going to actually calculate the integral. Find the area of the region between the curve y equals x cubed minus 6x squared plus 8x and the x-axis. Round your answer to the nearest tenth. So our two curves in this question are the curve y equals x cubed minus 6x squared plus 8x and the x-axis. Now the x-axis has the equation of y equals 0. So first I want to draw the picture before I set up the integral. Let me use my calculator to graph this cubic. So in my y equals menu, we'll type x cubed minus 6x squared plus 8x. Let me clear that out and try again. X cubed minus 6x squared plus 8x. And let's take a look at that graph. Okay. If we look at that picture, it looks like it crosses the x-axis at 0. It crosses the x-axis at 2 and crosses the x-axis at 4. And we can tell for sure if it does that if we set the two equations equal to each other. So if we let x cubed minus 6x squared plus 8x equal 0, then we can solve by factoring. We can factor out an x. That leaves me with x squared minus 6x plus 8. And then I can factor this quadratic to get x and x, 4 and 2, both of them minuses. We'll set each of these equal to 0. And we have 0, positive 4, and 2. So that graph we have crosses at 0, 2, and 4. So we get something that looks like this. Now we're interested in finding the area between this curve and the x-axis, which remember is the equation y equals 0, a horizontal line where y equals 0. So between those two curves, or bounded by those two curves, is this area here, as well as this area here. So these are the areas that we're interested in finding, and we have a formula for calculating the area between two curves. And that formula is the integral, the definite integral from a to b of f of x minus g of x dx. And the key piece of information we have to keep in mind is that f needs to be the top curve and g needs to be the bottom curve. We do that to make sure that the expression that we have inside the integral is a positive expression, because the definite integral only represents area when your expression is either equal to 0 or positive. So in order to calculate this definite integral, I noticed that on this portion of the graph from 0 to 2, my cubic is the top curve and the x-axis is the bottom curve. However, on the other portion, the x-axis is the top curve and the cubic is the bottom curve. So because the top and bottom curve change throughout the interval that we're interested in, we have to set up two separate integrals to find the area between these two curves. So representing this first one here, this interval, I'm going to integrate from 0 to 2. Those are my bounds on x. It starts at 0 and goes to this point 2. And my top curve is the cubic, x cubed minus 6x squared plus 8x. And my bottom curve is the x-axis, which is 0. And then to represent the other area, I'm going to find the definite integral, this time going from 2 to 4. Those are my x's, from 2 to 4. And my top curve is 0, the x-axis, and the bottom curve is the cubic. And when I add these two areas together, that's going to give me the area between these two curves. So now we will calculate these definite integrals. And before I do the calculation, I want to make the integrand as simple as possible. So I'm going to be simplifying these expressions. I can get rid of that minus 0 on the first integral and have the definite integral from 0 to 2 of x cubed minus 6x squared plus 8x dx. And on the second integral, I can get rid of the 0, but I do need to distribute that negative. So I have the integral from 2 to 4 of negative x cubed plus 6x squared plus, that would be a minus 8x dx. Now I'll be using the fundamental theorem of calculus to find the antiderivative. On each one of these terms, I'll use the power rule. So for x cubed, I add 1 to the power and divide by the power, getting x to the 4th over 4. And then for minus 6x squared, the antiderivative will be minus 6, x cubed over 3. And for 8x, I would have 8x squared over 2 using the power rule. Then I need to remind myself to evaluate at the bounds using that fundamental theorem of calculus. And I'll do the same thing with the other integral. The antiderivative of negative x cubed is negative x to the 4th over 4. The antiderivative of positive 6x squared is plus 6x cubed over 3. And the antiderivative of 8x is minus 8x squared over 2, and we'll evaluate from 2 to 4. Before I do my evaluation, I'm going to simplify some of these fractions. To simplify, I would have x to the 4th over 4 minus 2x cubed plus 4x squared, and then I'll evaluate from 0 to 2. I'll also have negative x to the 4th over 4 plus 2x cubed minus 4x squared, and I'll evaluate from 2 to 4. So now I'll apply that fundamental theorem of calculus. I want to evaluate at the upper bound. and at the lower bound and subtract those two values. So for the upper bound, I'll have 2 to the 4th over 4 minus 2 times 2 cubed plus 4 times 2 squared. Then I want to subtract. I'll put parentheses to make sure I subtract the whole thing. For the lower bound, 0 to the 4th over 4. That will be a minus 2 times 0 cubed plus 4 times 0 squared. We'll do the same thing for the second integral. We're going to evaluate at the upper bound and evaluate at the lower bound and subtract those values. I have negative 4 to the 4th over 4 plus 2 times 4 cubed minus 4 times 4 squared minus, I need parentheses because I want to subtract the whole lower bound. That's negative 2 to the 4th over 4 plus 2 times 2, cubed and then finally minus 4 times 2 squared. We've got a lot of arithmetic to keep track of, so we'll take our time. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 16 over 4 minus 16, 2 times 2 cubed. 2 cubed is 8, times 2 is 16. 2 squared is 4, 4 times 4 is 16. All of that stuff in the parentheses is 0, so that's minus 0. 4 to the 4th is 256. We have minus 256 over 4. 4 to the 3rd power would be 64, so 2 times 64 minus 4 times 4 squared, that's going to be 64 as well. 4 times 4 times 4. And I'm going to go ahead and distribute and simplify at the same time, so we have a negative times a negative, which is a positive. 2 to the 4th is 16. Negative times positive is a negative. And 2 cubed is 8, times 2 is 16. And then a negative times a negative is a positive. 2 squared is 4, 4 times 4 is 16. 16 over 4 is 4. I notice that I have a minus 16 and a plus 16. The 0 we don't need to write down anymore. Got 256 divided by 4. That's 64, so plus 64. 2 times 64, 128. Minus 64 plus 16 over 4 is 4, and I have another minus 16 plus 16 that cancels out. I notice I have a plus 64 and minus 64, and then I have 4 plus 4 plus 128. 8 plus 128 would be 136. I think I have a mistake somewhere, so I'm going to pause and see if I can find it. Okay, so I found my mistake. Let me highlight where it is. This is a negative here, and I left off the negative here. So that means that those 64s would not cancel each other out. So I'm going to erase my final few steps here and I'm going to make these corrections. I'm going to rewrite this as a negative 64, and I'm going to rewrite this one as a negative 64 because it doesn't cancel out. Alright, so now negative 64 and negative 64 is negative 128, which will cancel with the positive 128, and we have plus 4 and plus 4 from here, and so we get the answer of 8. So the area between the cubic x cubed minus 6x squared plus 8x and the x-axis is 8. On this question, we want to find the area of the region between the curves f of x equals 9 minus x squared and g of x equals x from x equals 0 to x equals 2. So first we want to draw a picture to represent this area. And we have f of x equals 9 minus x squared. If I rewrite this as negative x squared plus 9, I can see that this is a parabola which faces down, shifted up 9 units. So I'm going to draw a down-facing parabola, shifted up 9 units. It would look something like this. And then the second curve is g of x equals x. That is a straight line with a y-intercept at 0 and a slope of 1. We have this line here. And we want to find the area between these two curves from x equals 0 to x equals 2. So x equals 0 would be here, x equals 2 would be about here. So we're looking for this area. I'm drawing vertical lines at 0 and a vertical line at 2. And we want the area between these two curves. Now we have a formula for finding the area between these curves, and that is the definite integral from a to b of f of x minus g of x dx. And this is a little bit confusing because in my formula I use f and g, and we were given f and g. However, we can't assume that those are the same f and g that we're going to use in the formula. What we need to pay attention to is that the f is really talking about the top curve, or the curve that has the higher y values, and the g of x is representing the bottom curve, or the curve with the lower y values. So that's why we draw a picture of our curves first, so that we can see which curve is the top curve and which one is the bottom curve. So looking at our example, I can see that the parabola is the top curve and the line is the bottom curve. So it does happen to match up in this example, but you want to draw the picture every time to make sure that you're designating the right values. So now we're ready to substitute into our integral. And we're going to have the definite integral from 0 to 2. Those are our x values from 0 to 2. And then our top curve is the parabola 9 minus x squared minus the bottom curve of x dx. So we've got the setup, and then we'll solve this integral to find the area. So first I'm going to clean up by rearranging these terms. It would be negative x squared minus x plus 9. And now I'm able to find the antiderivative. of negative x squared minus x plus 9. That's negative x cubed over 3 minus x squared over 2 plus 9x. And we're going to evaluate that from 0 to 2. We're using the fundamental theorem of calculus, so we're going to evaluate at the upper bound and evaluate at the lower bound. Then we'll subtract those two values. We have negative 2 cubed over 3 minus 2 squared over 2 plus 9 times 2. That's our upper bound. Now we're going to subtract the evaluation of our lower bound. We need to make sure we put a parenthesis because we want to subtract the whole thing. That's 0, negative 0 cubed over 3 minus 0 squared over 2 plus 9 times 0. And we'll start simplifying. This is negative 8 over 3 minus 4 over 2 plus 18. All of this is 0. We'll subtract 0. And 4 over 2 is 2. And 18 minus 2 is 16. And I need a common denominator to add these two together. So I'll multiply 16 by 3 over 3. 16 times 3 is 48. 48 over 3 plus negative 8 over 3 is 40 over 3. 40 over 3 is approximately 13.3, well, let's say 13.3 since I said approximately. And let me read the directions up here. Round to the nearest tenth, and 13.3 is rounded to the nearest tenth. So the area between our parabola 9 minus x squared and our linear x from x equals 0 to 2 is 13.3. Thank you for checking out my videos. Have a great day.